Okay, in this lesson we're going to include the first two shortcuts to getting congruent triangles. And I'm going to kind of show you some picture representations of why they work before I get to the actual description of them. So the first one, let's say I've got a triangle here, and I measure the sides of each triangle, and I recreate those. So let's say, these are sticks. So I've got these 3 sticks, and they represent the length of each side of this triangle. And I say, here you go. Here's these sticks. I want you to put them together in a triangle. Well, there's only one way that you're going to be able to arrange these so that they fit into a triangle. Okay, it's going to have to be that way. If you change any of the angles here, they're not going to connect into a nice triangle. Okay, so there's only one set of angles that will ensure that they actually meet in a triangle shape. Okay, and those angles are going to match the angles that you had in the original triangle. So what this tells me is if I have 3 side lengths that are the same as the 3 side lengths of another triangle, then those triangles have to be congruent. The other one we're going to talk about is if you've got a side, another side, and they're connected at with a fixed angle. So here's what I'm given. I'm given this angle is the same as this one. This side is the same as this one. And this is the same as that. So I've got a side, an included angle, and a side. Included angle means it's the angle between the 2 sides. So 2 sides and the included angle. Well, the only way that I can connect these to make a triangle and keep the same lengths and the same angle is to just have this other side come and connect here. So I'll use an actual line. Okay, I'm going to have to do it this way. If you look, I ended up with the exact same piece there. Okay, so if you have a side, an angle, and a side, in that order, side, included angle, side, that's enough to know that the triangles are going to have to be congruent also. So here it is in words. We have the side, side, side postulate, which says if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. The other one is the side, angle, side postulate. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. And it's pretty easy when we're doing these proofs, as long as you're labeling and marking your picture, to see which postulate you're going to use to prove that the triangles are congruent. Because if you have 3 sides, that's the side, 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 and you can just list it as SSS. If you have a side, an angle, and another side, that's the side, angle, side. And these are the only 2 postulates that work for when you have 2 sides. There's one other one that's a very specific case that we'll get to kind of at the end of another lesson. But for right now, if you have 2 congruent sides, as a minimum, you have to either go for a 3rd side or the angle that's between the 2 sides that you have. So it's easy to see that the other option for this would be either SSA, okay, or if you went backwards with that, okay, you'd have an inappropriate word, and those don't work. Okay, so if you're spelling out something that's vulgar, you're not proving anything. Okay, because ASS is not a way to prove that triangles are congruent. You can only do SSS or SAS for 2 sides. Okay, we'll talk about which ones work when you have 2 angles and a side later. So I'll go through a couple examples of some proofs so you guys can see kind of how you're going to be using this on proofs. And some of the beginning proofs in your packet will use side, 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 and side, angle, side. So if you do the worksheets right away, and then you want to skip to the back where the proofs are and try to see if you can get side, 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 or side, angle, side, that'd be good practice for you. So the first one, I've got CG congruent to ZG. So I'm going to make sure I mark my picture. That way it's going to be easy for me to see what I need to prove at the end. So CG is here, and it's the same as ZG. Okay, and that'd be my given, so I could write that down. Case CG is congruent to ZG, because that's given. Okay, the next given is that M is the midpoint of CZ. That's also given. So what that means to me is M's in the exact middle of CZ. So that means that these are going to be the same. So I'm going to say that CM is congruent to MZ, because that's the definition of a midpoint. So at this point, I've got two sides on this triangle congruent to two sides on this triangle. I either need, okay, in order to side angle side, I would need the included angle here congruent to the included angle here. I don't have any other given information, though, that's going to allow me to get congruent angles. My other option is to get this side, okay, so CMG, this triangle, has this as the last side, and ZMG has the same line as its last side. So I need to prove that this is congruent to itself. And if you remember how we do that, that's one of the properties that we had very early in the year, the reflexive property. So now I've got side, side, side on this triangle congruent to side, side, side on this triangle. So I can say that the triangles are congruent. Make sure you list your letters in the right order. They'll usually have them in the right order in the proof part. So these are congruent by side, side, side. Okay, let's look at another one here. So I've got y is the midpoint of tx and SW. That's given. So y is the midpoint of tx. Here's tx. Y is in the middle of that. So that tells me that these are congruent. So I'm going to write that down over here. Py is congruent to yx. Okay, that's the definition of a midpoint again. And y is also the midpoint of SW. So that means these are going to be the same. Okay, I'll write that down. SY is congruent to YW. Definition of midpoint again. So at this point, I've got two sides. I either need ST congruent to XW, which I don't have any other information that's leading me to believe that that's necessarily true, or I need to have these included angles. If you look at the angles I'm looking at here, they are vertical angles, so I can say that they're congruent. So I can't say angle Y. I need to use three letters to describe this. So angle SYT is congruent to angle WYX. Okay, now it's important to list the triangle letters in the right order, but angle letters, the only thing that's important is to make sure you have your vertex point in the middle of your description. Okay, and this is because they're vertical. So now I've got congruent triangles. Because I have side, angle, side. So I've got one more here. This is going to be a throwback to last chapter. AB is parallel to CD. So I'm going to mark that on my picture. Okay, remember the symbols for parallel are these triangles. So these are parallel. And AB is congruent to CD. So I get two symbols, parallel and congruent symbols. So I'm not going to copy my given this time, so I'd have my givens. So parallel lines, okay, that gave us all those cool angles. So I've got to look and see which transversals I have. I've got this transversal here. Okay, so I could use that to get, this angle to this corresponding angle, but that's not really going to help me get in my two triangles here because I'm trying to get parts of this triangle and parts of this triangle. So that's not going to help me. And really, that's the only ones that I could use. So that's not going to help. I could use this transversal here. Okay, that looks like a more likely candidate. So this transversal, okay, if I look at this angle and this angle, okay, I've got an angle in this triangle and an angle in the other triangle. And if I look at my transversal, those would be alternate interior because they make the Z together. It's a little trick from last chapter. So I can say that angle ABD is congruent to angle BDC because they're alternate interior. So I've got side, I've got this angle now. Okay, so give them the same symbol. Now, I either need two more sides to get side, 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 or I just need this one side to get side, angle, side. Well, this side's going to be congruent to itself by the reflexive property again. And then I've got the triangles congruent to each other. My side, angle, side. Okay, so that's our first two shortcuts for congruent triangles. The next lesson I'll have two more.